Okay, good morning, class. Happy leg day. Let's go ahead and get started. So today we're doing mathematical background, which is basically chapter 2 of the text. As usual, we're going to be starting with the discussion section, and then hopefully we can get through it quickly and do the MATLAB assignment. Raise your hand if you already got started on the assignment, or not the homework, but the lab, right? Thank you for your honesty. I'm going to ask that you don't start the assignment until Friday mornings from now on, because I think the Wednesday class deserves that respect. So I think you need to give them that time. So they have until Wednesday evening at 10:45, and you guys have until tonight at actually it would be great if you guys can finish before the end of class today. But just for today, I'm going to give the extension until 11:45 p.m. tonight. And then if you still need more time, let me know, and then we can work something out. But otherwise, the labs are meant to be in discussion, right? So let's talk about some classroom items, because we're kind of confused about the attendance. So check this out. This is from the syllabus. So pay careful attention to the syllabus, because we have homework, which is 18% of the grade, as well as quizzes, 18% of the grade. So midterm is 7% of the grade. And then the MATLAB grader assignments that we're going to do today, every week in this hall, is 36% of the grade. So that's a really, really huge portion of the grade. So that's why it's really important for you guys to attend class. And notice that, there's no attendance on here. So technically, you're not required to come to class. Technically, you don't have to come to any of your classes. I mean, that's college, right? But it's really in your best interest to attend class anyway. So I'm seeing your faces. And then if this is the last time I see your face, and then I get emails week 8, week 9, like, hey, sorry, Miss Class, can I get some points back? It's going to be really hard for you to convince me at that point. So try to come to class anyway. And then that way I can help you guys. So y'all are witnesses. So you heard me say it. I'm not going to repeat this anymore. If you don't come to class, just email me. You don't even have to just say, look, I'm going to go on Zoom today. I don't care if you're sick or whatever the reason is. Just email me, and then I'll have it in records. But if you email me towards the end of the quarter, I'm telling you guys now, I told you in the beginning, come to class. I can help you out. Come to my office hours. So if it's at the end and you're asking for points back, it's probably not going to work. So same with the assignments. Again, the lab is 36% of your grade. So everyone hopefully at least should pass this class. I think everyone will at the very least pass. But it's going to be really difficult to, again, I'm speaking from experience here. I took this class in undergrad. If you have an 89.9%, you're probably not going to have that rounded, unfortunately. So that's why you need to come to class so I can help you get the points during the quarter, not at Friday, 4:57 p.m. when grades are due at 5:01 p.m. Understood? All right, sounds good. Yeah, so, and if you're trying to leave class early, again, this is college. You can leave right now if you wanted to. I'm not going to stop you no, come back, you haven't finished. No, I'm not going to do that. But you can just try to stay at least until, 10:20. Does that sound good? 10:20, 10:30. You can finish the assignment. You can do your homework for this class. And then you can read the book for this class. You can also study for another class. If you're really bored, I can pull up my graduate books. You can do those problems if you really want. Otherwise, just really try to stay until the end, and just try to keep coming in every Friday. I know it's Friday morning. It's the end of the week. It's 8 a.m. It's raining. So just try to keep consistent with that. Help me help you. That's the point. That's the message. All right. Any questions about that? Sounds fair overall? Great. All right. So let's get started. So like I said, we're doing chapter 2, which is mathematical background. This chapter basically covers all of the calculus that you should have already had by now. If you haven't had any of these, don't freak out. Just do your review. Just review your textbooks. You need recommendations. just let me know. So basically we have the calculus series, single variable, differentiation, integration, some vectors, matrices. So that's going to be today's lecture. If we can get to Cramer's rule, that'd be ideal. Differential equations, we won't be doing that today. We will be doing it in the future. So keep that in mind. And then some other stuff. So if I don't cover everything in today's chapter, then, go ahead and start to read chapter 2. And so again, you guys are the Friday class, so you're at the end. So ideally by now, you should have read chapters 1 through 3 by now, and then the appendix as well. So if you're behind on the reading, spend some time this weekend, because starting next week, chapter 3 and chapter 4, they pick up really fast. So we're gonna be doing a lot of stuff today really quickly. Sometimes I'll give you time to try out the problems. And if I'm going too fast, just let me know, and then I'll try to give you guys more time. So, yeah, so let's just start with literally the basics. If you have a mathematical object, you're gonna have some mathematical operations, right? Addition, then the inverse of addition is, of course, subtraction, multiplication, and then its inverse is, of course, division. Okay, so these can be operated on mathematical objects like numbers, like scalars, 3 plus 3, 4 times whatever, right? But these can also be applied to vectors. So we have vector addition. So who can tell me what it means, either visually, geometrically, or algebraically, what it means to add 2 vectors? Want to give it a shot? Mm-hmm. Mm-hmm. Yes, yes. Very good, very good. So in other words, if you have the components of the vectors, you have the x components, you add the x components, right? You have the y components, add those together. And then geometrically, what that looks like is you're adding the tail to tip method, right? Remember from physics? And then similarly, we have multiplication of vectors. So the first one is dot product. So the dot product, notice how, remember, if you don't know whether something is a vector or scalar in your textbook, some textbooks have boldface and some have little arrows. So if it's a little arrow, it's a vector. And so the dot product takes in 2 vectors. And then what does it output? What's the result of the dot product? It's a scalar, good. And the equation is the magnitude of the first vector times the magnitude of the second vector multiplied by the cosine of the angle between the vectors. So if you're trying to find the angle, use this equation. And then if you're trying to add the components, this means you're adding the x components and you're adding the y components, right? Whereas the cross product, again, we still have the 2 vectors as the input, but the output is what, a vector or a scalar? Vector. Good, good, perfect. Of course, we have calculus, so we have differentiation, integration. So what is a derivative? Yep, slope, slope of a tangent at every point. Integral, what's an integral? Antiderivative, good. What's another definition for an integral? Area under the curve, perfect. We have the determinant, transpose, and inverse, so we have some matrix operations. Today we'll be covering the determinant. In the future, we'll be covering the transpose and the inverse operations. And then we have some other multivariable vector operations. So what is this guy? What is del? Del operator, is it a vector or scalar? It's a vector. So in terms of, I kind of give it away because you see the little arrow, right? It's a vector. But I want you to recall the definition of the del operator. So you're taking the partial derivative of the x, y, and z components, and then you're taking those as the vector components in x, y, z. The gradient. So the gradient is an operator on a vector or scalar. It operates on scalar, and the result of the gradient is a vector or scalar. Scalar. Divergence. So now we have the dot product. The dot product is the vector components, right, for two vectors, A dot B. And so similarly, the divergence is a vector operation, but the result of the divergence is a vector or scalar. So if this is dot product, this is a scalar, so then divergence should be good. And so if dot product corresponds to divergence, which is a scalar, and cross product is a vector, that means the curl should be vector. Perfect. Yeah, hopefully that's pretty much everything. If I went a little too fast, please see me. And then yeah, that's basically all the calculus that you're going to be needing. Not even too much of this stuff. It's going to be mostly the linear algebra stuff. Okay, any questions about that? All right. Yeah, great. So we have some mathematical objects. So what is a function? I give it away. Okay, all right, so it takes in, what does it take inside the function? Yeah, all right, an input variable, and then it produces an output. So one example of that is you might have a temperature profile or a concentration profile. So this takes in three inputs, the spatial components of the system, and then you're looking at the change in heat. Let's say the change in heat over time or change in temperature. You might do that in your transport classes. So scalars, remember, think of scalars as just numbers. So the number 3 can be a scalar. What's an example of a scalar in the context of your major? Like chemistry, physics. Mass, good. What else? What are the scalars? I know you know scalars. Speed, temperature, distance. What about pressure? Volume. Okay. What about vectors? So what are some examples of vectors in the context of your classes? Gravity. Yeah, careful how you use gravity, because yeah, gravity is weird. Force, yeah, that's a little more general. Yeah, force. Okay. Yeah, so yeah, gravity as a force vector, right? We can have velocity, right? Momentum, acceleration. Yeah, and so matrices, now we're gonna have matrices as arrays of arrays, as arrays of vectors. Okay, so we're gonna be talking about matrices basically for this entire class. We don't have time to watch YouTube videos, but if you need recommendations, I have tons of YouTube videos. We can talk about mathematical objects in the context of physics, like speed and velocity. We can talk about them as arrays in the context of computer science. And then hopefully the mathematicians can reconcile those two definitions and give us a nice precise definition. So I want you to just whatever version you like the best, stick to that and try to review the other ones. Okay. So if you're really good at physics, try to understand the array definition for MATLAB. And if you're more comfortable with computer science, then try to review, you know, whatever vector definition is least comfortable for you. It's all about just practice. Practice makes perfect, right? So let's talk about calculus. We just talked about functions. So we have an independent variable goes inside the function, and then outputs a dependent variable as a function of the input. Differentiation, as we talked about. Remember, we have the slope of the tangent approaching the true derivative based on the definition of the limit. And then we have integration. So this can be represented by the integral under the curve, the infinite summation of each of the Riemann sums, the rectangles, right? And then we have the fundamental theorem, which connects these two ideas together. So the fundamental theorem of calculus, everyone write this down if you don't have this already ingrained in your head. So the connection between differentiation and integration is expressed by the FTC, which states that if a function is continuous over the closed interval and capital F is an antiderivative of little f, then we have the integral from a to b of little f, so f is the function, and then the result is the difference in capital F, which is the antiderivative. In other words, we can define velocity, right, as the derivative of velocity equals what? ddt of position vector, yes? Or velocity can be the integral of acceleration, perfect. And then the second FTC, which basically states that, so we have, if f is continuous, then we have the derivative of the integral from a to x of the function of some dummy variable. So it doesn't matter what the dummy variable is. You can call it a c, you can call it u, mu, whatever, but that's going to be equal to f of x, okay? So the FTC is really important because that's how we're going to be applying it to other systems. Probably not so much in this class, but you know, as engineers, we need to know the FTC. All right, so let's talk about matrices. So first we need to talk about matrix multiplication. First, we can do it element by element, and then we can do matrix multiplication just as in the actual proper definition, following the rules of linear algebra. All right, so everyone write down these two matrices. You have A, 9 components, 1, 1, 1, 2, all the way to 3, 3, and then B with these 9 components. So I'm going to give you 5 minutes to try to multiply these two matrices together. So the first step is to look at first row of the first matrix, first column of the second matrix. You take the inner product of those. That's going to be your first element of the output matrix. So matrix multiplication is an iterative procedure. So you're going to do the same thing again, where you keep the first row constant and move over to the second column, second matrix. Multiply those. Do it again for the third column. That's your output for the third element, right? And then you just keep repeating that process. So in general, we have this equation, right? So everyone write down this equation. So with matrix multiplication, the condition is that if we have a matrix A with m rows and q columns, and a matrix B with q rows and n columns, the condition is that these q's are the same. So what is m and q? What is q and n? So those are the indices. We have 1, 1, 1, 2, 1, 3. First of all, this is not 11, 12, 13, 21, 22, right? These are indices. The first element of the first row, second element of the first row, right? So the condition is that we have to have the columns of the first matrix and the rows of the second matrix, they have to be the same. Rows, comma, columns. Rows, comma, columns, right? So this equation is saying that if you want to look at the ijth element, so suppose we're looking at C12, right? Suppose we're looking at this element. First, we have to check if they have the same number of rows and columns. So first we check this condition. And the second step is we take this row, right? Just like this. Take whatever row we're looking at and whatever column we're looking at, and we're dotting those two vectors, right? And then you're adding those all together. So that's what this summation symbol means, right? So you're adding them all together. And then this is just a shorthand notation for summation, okay? So IJK, LMN, 1, 2, 3, those are just indices. Don't worry about the notation. Don't worry about what each of the variables, each of the indices mean. They're just indices. But the important thing is you have to understand whether you're multiplying the row and the vector, multiplying which two vectors. All right? Raise your hand if you've seen matrix multiplication before. Oh, good. Perfect. So let's take what we just learned. Let's apply it. So here you have these two matrices. And you have the multiplication. So first I want you to calculate it element by element. Multiply them element by element. And then I want you to multiply them using the equation we just described. So the first step, let's do it element by element. So what is element by element? We just take first element of the first row for the first matrix, first element of the first row for the second matrix, multiply those together. You're going to have 3 by 3 is 9, 3 by 3 is 9, 3 by 3 is 9. You're just taking 1 times 5, you get 5, 6 times 2, 7 times 3, and then that's your element by element matrix multiplication. So each element, right? That's what it means, element by element. Each of these numbers, 1, 6, 7, 2, 5, 3, 5, 2, 3. Those are all different elements of this matrix. Right? So that's not following linear algebra. That's just making up our own MATLAB matrix multiplication. But for the true linear algebra proper definition, we need this equation, right? Follow that equation and then repeat the steps. So the first row, first column, these are 2 vectors. We can dot those vectors. And then we have, this guy times this guy, 1 times 5, 6 times 4, 7 times 6. Repeat it for each of these. Now we have the second column, the third column, repeat it all the way until we have all the matrix, all of the elements filled out. So, therefore, in MATLAB, we have 2 definitions of matrix multiplication. So the matrix multiplication element by element, right? Remember, we use a period to tell MATLAB, I don't want you to do the equation, I want you to do element by element. So that can be useful if you're trying to just multiply a vector by a scalar or 2 vectors together and you just want it element by element. Otherwise, if you want to tell MATLAB, hey, I want you to do it actual linear algebra wise, then you take the 2 matrices that you defined and then you multiply it that way. All right, so that's the key difference. Regular, no period, element by element, period. All right, so let's try this out. Let's try this out in MATLAB. And then remember to let me know if it's like too small or I'm going too fast or you can't see the screen, something like that. We're just gonna see what this means in MATLAB. Okay, so the first step is what? We have to define our matrices, right? So we have A equals 1, 6, 7, 2, 5, 3, and 5, 4, 2, right? There we go. So we have our matrix. These are the same elements, right? 1, 6, 7, 2, 5, 3, 5, 4, 2. So that's telling MATLAB, let's multiply these together. Then we have B equals 5, 2, 3, 4, 1, 5, 6, 7, 3. Let's check that. I don't know why it's still asking me that. 5, 2, 3, 4, 1, 5, 6, 7, 3. All right. So, because I keep moving it. All right. So now we want to calculate the matrix multiplication element by element. Sorry, chat. Yeah. Let me stop this. Share screen. That's good. There we go. All right. Element by element. So let's call element by element. So now we're telling MATLAB, let's calculate it element by element. So what do we do? Do we need the period or we don't need the period? Right. So we do A dot times B, and then we run that. And we can see if our answers are correct. Right there. 5, 12, 21, 8, 5, 15, 30, 28, 6, right? And then we multiply A times B. So now we're just going to do C equals A times B. So now it's going to do that whole procedure on MATLAB directly. And then we see our answers. 71, 57, 54, 48, 30, 40, 53, 28, 41. Great. So now we can use MATLAB, right, as a calculator, right, to check if what we're doing by hand is working on MATLAB. So next, let's go back to the computer. Yeah, any questions about that? Good. All right. Okay. So next we want to do is calculate the determinant. So first we have the determinant of a 2x2 matrix. So again, remember the A11, A22, it's not 11, 12, 21, 22, it's just the indices. And so to calculate the determinant, who remembers how to do that? Good, good. So we do the crisscross applesauce. So we cross those, multiply those, and then the other side, subtract that multiplication, right? Raise your hand if you've seen this. Perfect, perfect. So that's going to be the determinant of the 2x2 matrix. There's also the geometric representation of the determinant. We don't have to go over it in this class, but it's going to be really useful for you if you try to recall what this means visually. And with the determinant for 2x2, it's regarding area. Okay. And so for the 3x3 matrix, the key is to identify where are the 2x2 matrices hidden within this 3x3 matrix. So the first step is to have the first element, and then you ignore everything vertically and horizontally, and you're looking at this matrix. Okay. And then the first element is your coefficient. So that's your coefficient of that first element, right, on this side. And then now we have the determinant of this matrix. So you multiply like this. So what's the second step? Go ahead. Yeah, A12. So now we're moving over. So everyone pay close attention. This is the tricky part. So the second step is we're looking at the second element, A12. So that's our coefficient. So some people like to subtract this guy right here, and then take the subtraction of this, and you crisscross it like that. What I like to do is I just like to keep it positive, plus A12, and then you're kind of moving over the matrix. So it's still a 2x2 matrix, right? You still see that 2x2 matrix, the A21, A23, A31, A33. You're ignoring everything horizontally and vertically, okay? So the only tricky thing, everyone, remember this. Either this is going to be positive and this is negative, or you're going to flip the signs. Whatever way you like better, do it that way. I like this way. Just be consistent with it, okay? And we'll do some examples. And then the last step is just like the first one. So we have A13, that's the coefficient, and then the determinant of this matrix, 2x2 matrix. Okay. Any questions? So if the 2x2 matrix determinant gives you the area, the 3x3 matrix determinant gives you volume. Good. All right, so the last step, we're gonna basically try to combine everything we just talked about with Cramer's rule. So Cramer's rule is gonna be your first sort of numerical method in this course. Cramer's rule gives you the solution of a system of simultaneous linear equations. Cramer's rule gives you the solution of a system of simultaneous linear equations. So let's say we have this system of equations. How many equations do we have and how many unknowns? 3 equations, 3 unknowns. So how many degrees of freedom? 3 minus 3, they cancel out. Degrees of freedom equals 0. So can we solve the system? Yes, we have 3 equations, 3 unknowns. So we can solve it manually. We spent several years in high school or whatever, right? Learning how to solve these manually. But now as engineers, we need to be more efficient. We need to use computers to solve it for us. So the first step is how do we reorganize? We have the X, Y, Z's. We have some coefficients. So let's try to reorganize this. I'm just going to see how we can write this in matrix form. The way we can do that is have this template. So here's your template. We have a 3x3 matrix. Your matrix multiplying it by a column vector, and that's going to output a column vector. All right. So what goes in these elements? What goes here? The coefficients. Very good. So this 3x3 matrix is the matrix of coefficients. So what goes here? 2, 3, -1, 4, 4, -3, -2, 3, -1. Good. This one is tricky. What goes here? 5, 3, 1. So that's going to be your output. That's the right-hand side. So raise your hand if you were lost there. So let's do it again. Let's make sure. So the first one is 2, first coefficient, 2. And this one is 3. So this is going to be represented by your X. This is going to be Y. This is going to be Z coefficients, right? So therefore, what goes here? Perfect. Perfect. So remember, the 3x3 matrix, your matrix of coefficients. You have your column vector. These are your unknowns. So what are we solving for? We're solving for that vector. So we're solving for, not only are we solving for X, Y, and Z, just like in algebra, we're solving for a vector of unknowns. And we're going to plug those X, Y, Z values into a vector. Okay, so there's no better way than to just do an example. So let's just use Cramer's method. Let's use Cramer's rule, and then we're going to see how we can solve this. So the first step is you need to rearrange the equation. So remember, in engineering, we're going to use the principles of science. We're going to derive an equation, and then that's going to give us the math. So that's the preliminary work. Once you have that equation, in this class, we'll give it to you. In your other classes, you have to get it yourself, right? In your fluids, you're going to be learning how to get your own equations. And then in the future, seeing those methods, right? But in this class, we're going to give you the math and say, all right, here's the math. Now I want you to write it in matrix form. So we have A. So what is A? The matrix of coefficients. What is X? Is this a vector, scalar, or matrix? It is a vector. So this X is this vector, right? And then what is B? It's the right-hand side. It's also a vector. Okay? Very good. So Kramer's rule states that if the solution exists, it is given by X of J is determinant of A prime of J divided by determinant of A. So Kramer's rule states that if the solution exists, it is given by this equation. So what's going on here? So let's look at the denominator. So what is this? Determinant of A. What is A? This matrix, right? So can we calculate that? We know how to do that, right? So we can calculate the determinant. So what is A sub J prime? So A sub J prime is the matrix formed by replacing the jth column of the matrix with the column vector B. A sub J prime is the matrix formed by replacing the jth column of the matrix with the column vector B. So that means that we're going to take X sub J, and then we're going to be looking at it for X, Y, and Z. So we're going to have three of these guys. Okay, so let's see how that works. First step is to calculate the determinant. So go ahead and calculate this determinant. First step, looking at the coefficient. First one is 2. Every 2 by 2 matrix, right? Calculate that determinant. Then you're looking at your second coefficient, 3. Again, if you want to subtract it and then take the determinant of the outer matrix, do that. You want to just add it, do that way, up to you. The answer should look something like this. You do a little math, a little bit of math, do a little bit of plug and chug, and then the answer is 20. So that's step 2. That's the determinant of the matrix of coefficients A. All right. So the determinant of A is 20. So now we need to apply the equation. So what's the equation? Determinant of A sub J prime. So the confusing thing is, what is this J thingy and what is this prime? So J is just an index. It's just an index. It's arbitrary. So if J equals 1, what is X? If J equals 1, X is just X. If J equals 2, X sub J is X sub 2. So X sub 2 is, so the first one is X. 1, X, 2, Y. If J equals 3, Z. X, Y, Z, 1, 2, 3, right? So remember in your physics classes, in your fluids, you have lots of 3D stuff. You do your right-hand rule. You're always going to be doing your X axis, your Y axis, your Z axis. Same thing. You're trying to solve for X, trying to solve for Y, trying to solve for Z. So if you don't know what is J, just plug it in. J equals 1, X. J equals 2, Y. J equals 3, Z. Perfect. So let's do X. So the first step, we have to replace the jth column of the matrix. So let's let J equal 1. So which column is that? First column, 2, 4, negative 2. Let's replace that by the column vector B. We're going to take this guy, plug it into right here, and then just rewrite it. It's going to look like that. We take V, just copy and paste it, put it right there. So now this is a new matrix. Call it A sub X prime. So now we have, look, do we have the denominator? The calculator, right? That's the determinant. Can we get this numerator? How do we get the numerator? take the determinant of this new matrix. So you do the determinant once, that's the denominator. You replace it, have this new matrix, get the determinant again. That's step one. You do that, that's going to give you your X value. Now you're going to do step two. Again, so you rewrite the matrix, but now you copy and paste this guy into the middle column, right? Calculate the determinant again. And then finally replace the last column last time. So this is your numerator for X, your numerator for Y, your numerator for Z. Now you just calculate the determinant once for the denominator and then 3 times for each of the variables. Repeat that process. You're going to get each of these equations. You have your X determinant, Y, and Z. Plug those in, and we're going to get, oh, I didn't include it. So that's your optional homework. Calculate that value. Actually, this is example 2.2 in your book. So check example 2.2 in your book. Any questions about that? Yes. They're going to be on YouTube, and then I have the link on Canvas. Yes, in my previous post. So check example 2.2 in your book, review that. And so step one, we try to organize the equations, have it in matrix form. A is your matrix of coefficients, X is your unknown variables in vector form, and B is your right-hand side of the equation in vector form as well. And then step two is calculate the determinant of the matrix of coefficients. And then you repeat that process for finding each of the X, Y, Z unknowns. Any questions? Great question. So you can do it manually. Do it manually. So let's say this is our matrix, right? And then let's do that example. Let's let B equals 3, 5, 3, 1, right? I'm going to define the new matrix A, 2, 3, 1, 2, 3 minus 1, 4, 4 minus 3, minus 2, 3 minus 1. And then now B is going to be what? 5, 3, 1, right? So if I want to replace the columns, the way I like to do it, when you're first learning how to code, you want to do it manually the first time, okay? You're getting used to the syntax, so let's do it manually. So let's call it A sub X, and then I'm just going to copy and paste this one actually. And so I'm replacing the first column. So that's going to be the 2, 4 minus 2. I'm replacing it with 5, 3, 1. So I'm going to be 5, 3, 1. And that should be my output for A sub X. So we have A is 2, 3, negative 1, 4, 4 minus 3, negative 2, 3, negative 1. B is actually a column vector, so I need to do that, right? Transpose it, and then A sub X is going to be 5, 3, 1, 3, 4, 3, negative 1, negative 3, negative 1. So that's how to do it manually. You just manually change it, build your own matrix like that. But there are other ways to do it. You can call the elements of the matrix. So you have your homework assignment that taught you how to do that. And then later on, next week, we're going to be doing for loops. So yeah, my recommendation is first do it by hand and then try to do like something to do it like a little bit more efficient. Okay, so let's take a look at this is your assignment for today. So A11, you can do this one first. This one's just like last week. You just define your elements, define your scalars and your vectors, and then you're going to want to plot this on MATLAB. So just be careful with the assignment because I need to check if it's correct. So if you have something wrong, it might be right on your MATLAB, but I need MATLAB Grader to check if that's actually correct. And then now you can use Kramer's rule, what we just learned. Now we're going to be applying that and solving it here. Let me tell you guys something real quick. There is a way to get the determinant on MATLAB. You can write det of A, and then I'm going to call that d sub t of the matrix A, right? So MATLAB has a built-in function that calculates it automatically, and I can call it det A sub x. That's going to be det of A sub x. So that's going to be the correct answer. From here on out, you guys can, after this assignment, you guys can use that. But for today's assignment, I don't want to see this function inside. I don't want to see det of A. I want you to do it either manually on paper, and then you can just say, you said you got the answer, right? And then you just say, I did this on paper. I promise I'm not lying. Okay, then I'll trust you. If you see this, if I see this, I don't like that. Or you can say, here is a function I made to calculate it, right? Just put some comments for today, because I want you guys to practice doing a little bit of matrix stuff just for today. And then, yeah, so don't do this. Don't use the MATLAB built-in function det of A. I don't want to see that. Okay. So let's take a look at the assignment. So we have the equation. All right. So the first step, define your matrix of coefficients, define your vector, and then calculate the determinant. Store it as a variable like this, but again, do not use the MATLAB built-in function. Do not use the MATLAB built-in function. Then finally, the last step is to define it as alpha, beta, and gamma, because these are your unknowns. But MATLAB doesn't know what alpha is. So let's say you type in alpha, right? Where is it? Alpha symbol. Let's say you type in this. There's a hex code for it. MATLAB doesn't know what that is. MATLAB doesn't know what that is. So let's say you get the answer, right? MATLAB doesn't know what that is, so just type alpha equals whatever is your answer. Okay, any questions? All right, go ahead and get started. Yeah, let me know if you have questions. And then, yeah, again, this is due at 11 a.m. This is due at 11 a.m. Try to finish by today. If you don't finish, this is open until 11:45 p.m. If you still need more time, email me. And then I'm going to stop this, but I'll stay on.